The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. This is Kendall Trump with Grain Journal Magazine in Decatur, Illinois. Welcome to today's webinar, Filter Bag Performance and Maintenance Best Practices, presented by Kice Industries. Whether it's filtering, pneumatic conveyance, blending, dust control, or a complete processing facility, Kice works closely with customers to deliver the best solution they need for their process. Today's presenters are Jeremy Rupp, Installation and Field Services Rep with Kice, and Lonnie Glen, Kice Technical Sales and QuickShip Manager. Please feel free to submit questions at any time during today's presentation using the questions box at the right-hand side of your screen at any time during our presentation. We will be addressing your questions in a Q&A session following the presentation. Also, please note that this webinar is being recorded and a link to the recording will be distributed to all registrants tomorrow. Also, this webinar will be available on our website for viewing within 24 hours. At this time, Lonnie and Jeremy, can you please do a voice check?
Voice check.
Thank you. And Jeremy, are you there as well?
Yes.
Thank you. Okay, and now Lonnie, can you please show us your screen? There we are. Ladies and gentlemen, here are Lonnie Glen and Jeremy Rupp.
Thank you, Kendall. Thank you for allowing us to do this. Very nice introduction, and we'll get going on this so we can give you a little bit of information from Jeremy and I. Key points today: bag cleaning systems, problems and symptoms, some best practice, best maintenance and operation practices, some key operational tips, and some maintenance tips as well. I guess I'm backing up because I'm not sure who all is in our audience, but I guess I want to make sure everyone understands the purpose of a dust collection system and the filter bags specifically. But they're to collect fugitive dust to a central location and safely vent clean air back into the atmosphere to protect personnel, the equipment, the process, and the environment. An example of a dust collection system, again, big picture, it's a series of dust collection points back to a Baghouse filter, whether it's ours, whether it's MAC, whether it's Airlandco, whoever it is, and the size doesn't matter either, it's still a dust collection system. There's interconnecting ductwork that brings it back to the Baghouse filter. Typically, there's an air seal in the form of a rotary airlock on the bottom of the dust discharge. There's a suction fan to pull suction from all of the points equally. And from there, you can add things like a blow line, a pneumatic conveying system to blow dust to a dust bin at a grain elevator or to a feed bin, something like that. Common terminology used in dust collection systems: FPM, measured as feet per minute, it's the speed or the velocity of the air. CFM, cubic feet per minute, it's a nomenclature for a volume or the amount of air that's being pulled through the system. Duct velocity is how fast that product is flying, how fast that dust is flying. I like to use grain dust, typically has a minimum of 3,400 feet. I've heard it as low as 2,800. I tend to use about 3,400 in talks that I do, whereas wheat conveys at around 4,200 feet per minute. So if your velocity is too high at your pickup point, this is where you get to the point where you pick up good product. Static pressure is the pressure used to overcome the resistance of the tubing, the friction on the inside of the tubing. It's usually the longest run, but not always. It depends a lot on the line size. Velocity pressure is a way to measure velocity. It's air traveling at a given velocity. And then area is just a simple mathematical measurement of the inside of the duct. And we typically talk about area in terms of square feet, not square inches or meters, but you can make all those calculations that you need, but we talk in terms of square feet. Common terms in our industry related to dust collection systems: air to cloth ratio. Basically, this is what establishes your design. It's a ratio between the CFM that you want to pull and the total area of the filter bags. My example here is 15,000 CFM and a filter that has 1,555 square feet. A division means that air to cloth ratio is 9.65 to 1. A rule of thumb for general suction, cleaning houses, elevators, 7 to 10 to 1. It used to be much higher, 12 to 1, 14 to 1. But that has since been lowered for the most part because people don't want to change their bags every 6 months. Secondary collectors, high humidity systems, we try to stay at 7 to 1, maybe 5 to 7 to 1. Filter receivers, central vacs, bin vents, try to stay around 5 to 1. And and we'll talk about this a little bit later, but for pleated filter bags, we try to stay between 3 and 5 to 1 for pleated filter bags. Can velocity. Can velocity is something that we measure in terms of what's that dust doing inside that filter. Can velocity is the open area between the bottom of the bags and the hopper discharge. What's that velocity? If you throw up a handful of dust, you can see it start to float down. That's that can velocity. The interstitial velocity is a little bit different in that it's measured between the filter bags. It doesn't take into account the area of the filter bag. So the interstitial velocity is actually more key, and we want that to be low enough so that dust, when the fan is off, will drop out of the airstream. And there's a little chart there for bulk density of materials and typical filter can or interstitial velocity. A lot of people use the terms interchangeably. To complete a dust collection system, fans and fan curves. Most all of us as manufacturers have different fans pretty much doing the same thing and different things, high static, low static. In a general dust collection system, again, whether it's Airlanco or Mac or whoever it might be, you're talking about a 20-inch water column fan for general dust collection and dust control. You can have material handling fans that are built a little tougher. You can have high static fans that can get up to 38, maybe even 45, 60 inches of water, depending on the manufacturer. And there are different types of fans. There's different rotations. There's different orientations. Whatever works best for your system. When we design a system, we always have to have a starting point. And at some point in this instance, maybe this is a hammer mill lift system, someone said, we need 5,400 CFM, and I have 26 inches of static pressure. Well, I can look at this fan curve and see that if I ran that fan at 3,500 RPM, follow my red line over to the right, I'm going to need about 41 brake horsepower. That's a good design. This is how I figured out what I'm going to need. And again, this is at standard air and drive losses aren't included. Now, in the green, this is when I have clean bags. So maybe I don't have as much static as I designed for. Instead of 26 inches, I only have 21. Well, if my fan speed remains at 3,500 RPM, you can see on this fan curve that I'm now going to pull 6,200 CFM, and I'm going to increase my brake horsepower to 46. So with less static, I have higher CFM. And now things run a while, they run a year, maybe some changes have been made. I've got dirty bags. So now I have higher static of say 29 inches instead of my 26-inch design. So my air volume has gone down to 4,800 CFM. I'm still at the same speed because I've made no adjustments to the fan. My brake horsepower is actually less. And what the result of the blue line is, I have the static that needs to get the job done, but I'm not getting the air volume to get the job done. So it's got to be rebalanced and get back to that more of that design, that red line that we've got there. So it kind of brings us back into a complete system. Again, dust collection hoods and pickup points, interconnecting ducting, a filter, an air seal, and a suction device to pull that required static. Typical baghouse controls, again, most everybody's filter is going to have a pressure gauge so you can read the air tank pressure for the bag cleaning. Ours happens to have a palm button so you can instantaneously read the tank pressure. It also will have a magnehelic gauge. It's a $90 item from Dwyer. It measures the pressure differential across a clean and the dirty housing, and it's measured in inches of water column. It's mounted on the filter near the door, visible to the operator if you climb the catwalk. Personally, when I sell filters anymore, I try to add a second one that is down low, maybe eye level on the structure. It's just a little extra tubing, a few more hose barb fittings, and another bracket and magnehelic, but it allows the operator not to have to climb up that catwalk and ladder to look at the pressure differential. So it's kind of I just call it a second gauge assembly, and it's a pretty cheap way to save having to go upstairs, ladders, climbing points these days. We can switch out the magnehelic and include a photohelic or a digihelic, basically a pressure transmitter that'll output a 4 to 20 milliamp signal to your control system so that your control system can see what that pressure differential is. Again, eliminating the need to physically climb the ladder in good weather, hot weather, bad weather, just to read the pressure differential. Timer boards are typically in an enclosure. They hold an electronic timer board that allows for you to adjust for the application, all your wiring to a central location. It's got a red lights to show that it's in operation, and it gives you some adjustments. Problems that tend to come up on bag cleaning systems, a lot of them have to do with the timer board. If they're not sealed and they get water in them, they're electronic, they're going to short out. If you have your on setting and off setting out of adjustment for your application, you're going to have problems. Your firing sequence can be an issue, depending on how the electrician wired it. In this case, in my presentation here, I say if the pressure, the frequency, and the amplitude, which is how much force is being put on the filter bag, are too low, then I don't get my dust cake layer built up, and my bags don't get as cleaned as they can. So I've got higher pressure drop, shortened bag life, lower than anticipated volumes. Conversely, if it's too high, I may be over cleaning the bags. I might get to a point where I've got so much suction on them that I've got rips or tears in them. It may prevent the dust cake from building up. Maybe some small particles will bleed through. So, and plus it's a waste of energy. It's a waste of that compressed air that you are paying for, whether it's in a PD pump form or compressed air. But here's just a close-up of the on and off. They can be adjusted by hand or with a small screwdriver. We don't set a filter when we ship it based on your application. We tend to have a default setting of about 150 milliseconds on with an off time of 50 seconds. Now you might say, well, gosh, 50 seconds is so long. I don't think you may not think it's working, but it's a starting point. Adjust it for your application. Adjust it for your dust. If you have a low dust load, there's no sense in cleaning the bags every 10 seconds. Let it clean, let it stay off for 50 seconds, then the next row blows, then 50 seconds, the fourth row or fifth row blows, that kind of thing. You can adjust your off time so that you want it off long enough to build up pressure in your compressed air system or your blower system. You want it on just to provide a good blast of air. Personally, there's not a whole lot of difference between 150 milliseconds and 300 milliseconds. The longer is not necessarily better. It's not necessarily worse. It's just a very short time of a blast to blast out of air on the inside of the bags. What is important is if you have a compressed air system, is that you adjust the regulator providing that compressed air to 80 psi, or maybe for a little better cleaning, you can go to 90. We can go up to 120 on our filters, but do have a regulator in the system because you don't want 150 plant air. It'll tear the bags over time. So there's positive and negative to each adjustment. Again, these are pictures of a Kice Venturi jet system. Basically, it's a solenoid valve with a small brass nipple to the blast valve, a right angle blast valve. Very simple. The blast valve only has two working parts, a diaphragm and a spring. Typically, if something's going to go wrong, most often what I see, and I'm sure Jeremy would agree, is that solenoid valve gets bent. That nipple gets bent, gets broken, gets cracked, and will somehow leak air out there. Cracked diaphragm, maybe the red cap on the solenoid is gone, and we lose the ability to pull that core up into the solenoid. Hose connections can dry out. Maybe there's no regulator or filter. We definitely want a filter because, especially outdoors, cold compressed air will condensate out and you'll get some moisture in the line, and all you're doing without a filter in there is putting that moisture right into the air tank, which is putting it into the inside of the bags. And maybe there's low cleaning pressure. One thing that is important probably on everybody's valve is when the valve's operating correctly, you'll feel a little puff or blast of air through the discharge of the solenoid valve. A Kice PD system that takes a PD blower, which is very common in elevators due to the lack of really good, clean, compressed air. It takes a larger valve, a 3-inch valve. We call it a new jet. That diaphragm can crack. That spring can break. That solenoid valve can fail. So those are kind of the primary things. Maybe the timer board gets damaged. Maybe you're having high heat blower issues, that kind of thing. So there's a couple other issues that come along with a PD blower system. But what you're not doing is you're not putting any oil into the system with a PD blower issue either. And again, when the valve's operating correctly, you'll feel a slight puff or a blast of air when it's operated. Filter bags. Filter bag media. This is kind of one of the points that we wanted to talk about today. Selection of the right media plays a major role in your performance. You got to consider lots of different applications. So we ask a lot of questions, as I'm sure the others do too. Operating temperature, humidity or moisture levels. What's the size and type of dust? So many of us, the reason we're here is typically grain dust, okay? But there's lots of other things. There's DDGS dust. There's a multitude of grain-related dusts. Small corn from a hammer mill operation, that kind of thing. Another question, a factor that comes into play is resistance to abrasion, or maybe there's a chemical relation to it. Moisture. What's your filter air to cloth? Maybe there's an engineering firm that has written not to exceed 7-to-1 air to cloth ratio. And another one is it an NFPA compliant filter? That's becoming a bigger issue today. And with NFPA compliant filters, we need to look at the proper filter bag, not so much as the filter bag itself, but is that filter bag grounded? So that's a key point. And in this slide right here in the lower right, you can see that gray material. That's actually the grounding strip for that filter bag. Most common in our industry is a 16-ounce singed polyester felt material. It's worked well for, I couldn't tell you how many years, but it's worked well in our industry for a long time. It's inexpensive these days. It allows for a complete bag change out. It used to be 12 ounces. It's gone to 16 ounces now. They can be washed, maybe reused. Kice standard is a 16-ounce singed polyester felt material. We also have a 12-ounce singed Duratest material, which is a slightly different polyester felt material. Our bag cleaning is based on depth filtration, where you build a dust cake up on the surface of the filter media, and that then will not allow smaller particles to get in. And so you're using a dust layer to help increase the efficiency of your filter bags. You're limited in air to cloth ratio on some of these bag houses. You don't really want to put a bag house with, I would venture to say, over 12 to 1, certainly not over 15 to 1. You're just asking for trouble. High moisture and temperatures will also limit the use of standard polyester type bags. The hydrolysis can occur where it breaks down those fibers. High temperatures are involved. So a standard polyester bag is probably not the right answer for that kind of an application. Media is challenging when there's warm and moist air from pneumatic conveying systems. So all of the manufacturers of filters, all of the manufacturers of filter bags, they can put glazing or coatings on these filter bags. We call it eggshell or defender coats. Polypropylene is another fabric material. They also make an oleophobic polyester that can be used in high temperature, high moisture applications. And then from there, you go to what we call surface filtration, where surface filtration, there's little or no particulate penetrating the media itself. It's all on the outside. That's where Teflon coatings come into play, a Gore-Tex type coating, other coatings that are available that are really, they don't penetrate the material, they're on the surface. But they can have drawbacks as well. They're very expensive for one thing. And if you're not penetrating and getting that dust, they can blind over quicker. I got this from BWF back in 2002, I believe. It's a good chart that I use. It's just basically a common listing of different fibers, their recommended temperature limit, and a kind of a description. On the left-hand side, right below the blue line, there's polyester, which is typical in our industry. It's good to 275 to 300 degrees. Good resistant to acids. I don't know if I agree with that, but economical, I certainly agree with that. It's predominant in dust collection due to the higher temperature resistance, but it can be susceptible to hydrolysis above 150, where it'll break down some of those fibers. You turn around and you go on the other side, and there is PTFE, commonly called Teflon. It can handle applications up to about 500 degrees. Everybody knows about Teflon or polytetrafluoroethylene. It's very good in acid applications. It's got low friction coefficient. It is expensive. So you kind of have to weigh off a $50 filter bag versus a $5 filter bag. Glass, that last one at the very end, again, high temperature, but for food safety reasons, I don't know of anybody that really uses fiberglass material as a filter bag media. So we kind of gone away from that over time. Another chart, again, this one from Donaldson. It lists across the top fiber type from polypropylene, polyester, homopolymer acrylic, aramid, which is kind of a Nomex, a fire retardant type material, all the way to PTFE. Then it lists continuous operating temperatures. As you can see, the charts between the two are fairly consistent. This polyester is continuous operating to 275. And if I go back, polyester is listed in the lower left at 275 to 300. Again, resistance to hydrolysis, resistance to acids. It's a good chart to give you an idea. And at the very end, there's a relative cost versus polyester. So you've got a polyester as, say, a baseline of 1. And if you look over at PTFE, it can be as much as 25 times as expensive. This is not new to our industry. It is growing. but standard filter bags, cloth singed polyester type filter bags versus pleated filter bags. There's a lot of pros and there's a few cons. I would say that there's probably someone in the industry that was much smarter than I am when it comes to this kind of thing, that can explain all of these things and make it sound like it's great. To me, the best thing is you have more filter media. You get 2 or 3 times the filter media area with a pleated filter bag versus a standard cloth filter bags. It's common to have 25, 30, 35, 40, even 45 pleats. It does require less compressed air. You can clean them typically between 60 and 90. It can reduce the overall height. A lot of these come into play in new applications where we don't have unlimited space anymore. We don't have unlimited heights. So I've got to get my filter with this much area into this much headroom application. It decreases the can velocity, but not the interstitial velocity, because I've got a lot more area, and I've got more area because my bags are shorter. Typically, these type of products, if ordered correctly, have FDA food safe compliant materials in them. And they do have a sewn in grounding wire. Again, you've got to order them that way. Some of the cons I talked about earlier requires a lower air to cloth ratio. It can clog in between the pleats. Now, I'll show you on the next slide a free flow design, which means there's no puck at the bottom. And so that flour, that dust can drop out, that grain dust can drop out. But again, this picture I show to the right has a puck there, and product can wedge in there and not get out. If you don't change your air pressure, you may have too much air pressure, because 120 psi is probably going to push that pleat out, and then it's not coming back in. So you're losing some of your effectiveness. Entrapment, just talked about, and they are more expensive to replace. Again, that all being relative, but you're going to have shorter bags, but they're more expensive to replace, but you do get much more filter media. Here's just some information on some of the pleated filter bags we offer. Again, we have a whole gamut of descriptions. We've got standard spun bond polyester. We can add a hydrophobic and oleophobic finish to it. We can put a conductive grid in it. We can put PTFE membrane in it. We can do both. They come in typically 0.5 meter, 1 meter, 1.4 meter, and 2 meter lengths, which you can see in the chart shows the lengths, and also the area at 45 pleats. At the lower right, I did in red there, it says an area comparison, square feet of filter media. A 10-foot standard Kice filter bag, 11.78 square feet. That's just something we know. A 2 meter or 6 foot 5 foot length, 45 pleat Kice pleated filter bag is basically 35 square feet. So that's 3 times as much filter media with a pleated versus a standard filter bag. Poor Baghouse performance. Why does the filter media make an issue? Well, premature increases in pressure drop, short bag life, low air volumes through the filter may have something to do with the bag that you've chosen. Air to cloth ratio could be acceptable, but it's a high temperature, it's sticky, it's fine. Maybe you need to switch to something that is glazed or treated, or switch to a surface filtration type of filter media. And higher air to cloth and using polyester bags with depth filtration, switch to a surface filtration. Again, there's a multitude of bag construction, polyester, polypropylene, nylon, that kind of thing, and switch to something that would give you some better protection on the outside and not get into those depths of the filter bag as easy. Let's say your baghouse is dusting out. You look outside and your baghouse is dusting out. Your stack emissions, the neighbors are going, "Hey, I can't see my car." Well, there's probably worn bags. They've got tears or holes in them. Bags are missing. Maybe they weren't installed. They've fallen off the tube sheet. bags might be okay, but the tube sheet is worn. It's cracked. It's damaged. There's leaks through it. So that may not have to do with bag media, but of the type of material, but it's a symptom of what's going on. There's holes, they're missing, there's tears, there's something related to the filter going on. One of the biggest things we're seeing anymore, and this happens a lot in cooler applications, cooler, drier applications, temperature differential leads to condensation on the interior of the baghouse. You've got a higher temperature coming in on the inside of the ducting, on the inside of the equipment, yet outside it's cold. At some point, you're going to have condensation because of that colder outside temperature. You've reached a dew point, condensation is going to form. And we'll talk about this a little bit later, but problems, when you get dust and moisture combined, you got mud, and that can be tough on filters, tough on filter bags. So at Polar Vortex, we had two, not this winter, but winter before, in some of our customers in the north, gosh, problems I'd never seen before were coming out of the woodwork because of how cold it was, and you couldn't insulate equipment well enough to work in that polar vortex that we had. Kind of leads me to this slide. You know, spray-on foam insulation or thermal insulation, putting a building around it. You've got to keep that skin temperature closer to your air temperature. You can use controls and other temperature probes and other controls to change the logic in your control system to get your internal temperature and your external temperature and your process temperature as close as possible to reduce that condensation forming, because that becomes a mass of moisture that the filter is going to see. And it takes one of our engineers, one of the other guys' engineers, some good time and design time and engineering to make sure in a drying or a cooling application that you're getting the right baghouse, you're getting the right filter bags. Be careful about recycling air in these applications. Everybody wants to recycle the air to save BTUs, but again, in one particular instance I had that I fought a year ago, it was insulated. We were getting there, but then they recycled the air back in an uninsulated line. So it was great to the fan discharge. Then in the fan discharge, when they threw the switch and put the damper so it went back in, it went through 50, 60 feet of uninsulated line, hot air, cold outside. Basically, it made nice warm water coming into the blower that went into the dryer. And again, there are specific filter bags that are designed for moisture and for heat. A few pictures I've garnered over time. Some of these, unfortunately, are just ugly. I couldn't tell you what happened with all that material that's stuck in there, but it could be moisture, it could be a higher than expected dust load. You can see what it's done inside that filter, and somebody's got to go in there and clean it out. The second one, missing bags. Again, whenever I see cages on the ground next to the filter, I always look for this, because typically that's the reason you're getting dust coming out your fan, coming out of your discharge. Here's a pleated bag. Again, I can't tell you if it was moisture. I can't tell you if it was low cleaning pressure, if it was a fine product. But the things I talked about, some of the cons I talked about earlier, are very evident there. Moisture just won't clean them. Maybe 40 pounds of air was not enough to clean them. And unfortunately, on that farthest one, maybe the discharge size on the hopper was too small, and we had a big dust load and it just couldn't carry it out. Here, heavy dust load. They hadn't ran the cleaning system in over a year. It had about a 1/4 inch of fine dust on it, just blocked those bags. Just couldn't get through. Middle one is a clogged hopper. Customer was kind enough to write clog in the middle of the clog just in case I didn't see it. But they were also shutting down their airlock after the system was shut down, but before they blew the bags down. So all that material just came off the filter bags right into the hopper, bridged over a little bit, and then couldn't clean. And the last one, we're picking up some good fiber material. That was his money. So we had to cut back on airflow just so we wouldn't pick up his high dollar fiber that was getting into the filter. A couple main best practices that I can think of, and Jeremy will come in with some others later. When you change all your filter bags, change them all at the same time. Because if one's blinded over, if you change 30 and they're blind, and you don't change the other 30, you're going to have higher problems because you can pull more dust in through those 30 that were clean. And also periodically clean bags offline when the system is down. It improves bag life, filter performance. It's important to keep the airlock, the screw conveyor running so that you can discharge that dust into the next process. And if the bags are blinded over, do what you can to shake them off, clean them off, blast them overnight, blast them for 2 days. You might be able to recover enough performance until you can get to a scheduled maintenance bag change. And then we're always asked this question, pretty much everybody at Kice is asked this question by customers, when do I change the filter bags? Our rule of thumb, and I learned this from the Kices, is use 6 inches on the MagnaHelic as an indicator to change the bag. That gauge goes 0 to 10 inches. When bags are new, there's very little pressure drop across them. They're going to read 1/2 inch, maybe not even that, very little. And then they'll start to get that dust cake on them. And they'll start to build up a little bit more, and it'll probably stay at 1 inch, maybe 1.5, maybe 2 inches for many, many months. But then when enough dust particles get embedded into that filter, it's going to start to climb, and the cleaning process just doesn't get them all out. So now you see it go to 2, to 3, to 4. I say keep going, but at 4 inches, when you're consistently seeing 4, maybe make sure you've got a set of bags on hand. And then as it cleans and it gets to 5, cleans and gets to 6, it goes up to 7, but it cleans to 6. Just around 6 inches, that's the time to schedule a bag change. Has nothing to do with how many months, how many days, how many weeks. It has to do with the pressure differential. You might get 5 years. We have guys who get 5, 6, 7 years out of a set of filter bags because it's used intermittently. It's a central bag cleaning system. It's not used all the time. It's a very light dust load application. And conversely, we have customers who say, I've got to change my filter bags every 6 months. Well, you got a high air to cloth ratio. You've got other issues. You've got a product that's sticky. You've got a product that's moist. It is what it is at some point. I'm going to turn this over to Jeremy right quick and let him tell you a little bit about filter bag installation. Jeremy?
Thank you, Lonnie. Filter bag installation it's generally fairly simple. I know our bags are 2 inches longer than the cages. And this is something that I find a lot when I go out to troubleshoot different filter systems. And a lot of the times whether the contractors or sometimes it's a new employee that installed the socks onto the cages, and what they forget to do or they're not trained to do is tuck that 2-inch sock into the cage before you install it onto the thimble on the tube sheet. And then the next thing that's missed, there's also a little sweet spot where that rib falls into the the indention on the thimble. If those things aren't done correctly, there's a couple of things that can happen. You can actually lose a sock. I think on the next slide, there is the sock can actually slide down the cage, or after the cage can actually come off that thimble, and then you're digging out a sock or a cage inside an airlock or conveyor. Lonnie, if you can go to the next slide.
Okay. One thing I'll point out before I go there is that Kice, and I'm sure other manufacturers do, they make a series of safety gratings that can go inside across the stabilizer bars on the filters, so that a person can go in and tie off and be able to reach those filter bags. So we've got those available as needed, and they're retrofittable to any filter, whether it's 50 years old or brand new. Here you go, Jeremy.
Yep, thank you. And that's where, this is what I was talking about on the, if it's not installed on that sweet spot where that rib fits in to the thimble. If you can go to the next slide. Now on top bag filter installation, it's you don't actually install the sock onto the cage. You actually drop the sock into the hole, and you snap it in, and then you drop the cage down onto it, and then you put a tube sheet holder or the platform where the cleaning arm actually goes over to clean the sock. This is a little bit simpler. Sometimes it's a little bit quicker as far as installation goes, and so it's a different way to. It's just a different type of filter. Go ahead and go to the next slide.
Okay. Thank you, Jeremy. We're going to go through some of these Baghouse filter operation and maintenance tricks and tips. We're probably going to go through them a little bit quicker. We're running on time, but we've got a few more slides to finish up. But basically, when Jeremy's out there, when I'm out there, when I'm on the phone with someone, we've got to get down to the basic root. What's the problem? What's the problem? My Baghouse filter doesn't work. What's piece of equipment? Everybody always thinks it's a filter, but really it could be a multitude of things. So we really got to dig to get to which piece of equipment, and then we have to dig what is the issue, because that helps drive us to what we can do to help you solve that problem. What equipment? I just was saying that. Is it the filter? Is it the fan, airlock, screw conveyor, hoods, the duct? Maybe it's the product. It could be the air system under the discharge. Dust bins full. We dig, we ask enough questions, we go on site and we look, trying to determine what equipment it is so we can work towards the solution. What do you look for in your dust collection system has an issue? Again, here's a laundry list. What changed? That's the number one thing. Fan rotation, cleaning system, filter discharging product, lack of suction, wet product, bridged. Does it happen only during the polar vortex? Does it happen only during 30-degree days, and it doesn't happen at when it gets up to 40 degrees? Do you hear new noises? Are you pulling good product over? Did you have a fire or an explosion? It did work at some point, and now it doesn't. Kind of goes back full circle. What changed? And what I've done is just put together a number of answers to some of those questions I just asked. What changed? Somebody may have adjusted a damper. You always want the system under a slight negative. Maybe a motor on a fan was changed out. Filter bags were changed out. Somebody added in, I'm going to stub in a dust port. Nobody will know. Or maybe you closed off a dust port and now you're starting to pick up good product. The number one thing that I think, if you called Kice Industries and talked to our technical guys, any of our technical guys, any of our installation guys, and you said, hey, my dust system's not working, the first question I think we would answer, and forgive us for asking this, is the fan going the right direction? It's associated with a motor change out. You get the motor leads reversed, it runs backward. A fan running backward will pull air, just not as much. So you think it's working, but it's really just not working enough. So that's always the first question we always ask. I would say, forgive us for asking such a dumb question, but many times it is the cause of the issue. Jeremy?
Is the cleaning systems operating? Is the compressed air on? A lot of the times when I go to a facility, I try to shoot. If I'm troubleshooting, I'm looking for 100 psi. And I know that's kind of in between 80 and 120 what we can actually use on our systems, but I try to get the compressed air set closer to 100. You should hear the noise from the air discharge on the cleaning systems, on the solenoids. Your motors, are the controls working properly? Are they, the timer board? I like to look at that compressed air. I like to see it drop from 100 psi to 60 psi, just to make sure I've got good pop. And that's just kind of what I'm looking at when I go to troubleshoot different facilities. Make sure the timer board's firing. Is the filter discharging product? If the airlock's leaking, it may be pulling air up from the discharge and causing turbulence inside the filter, causing the hopper not to empty. Is it full? What kind of material is it? Is it light? Is it like light shaft holes, bees wings? And look at the equipment after. And then, of course, the high can and interstitial velocity. Those are the things we got to look at. Go ahead, Lonnie.
Again, all these things are intertwined, but is there a lack of suction? It's some of the same things. Is the fan running backward? Is the line plugged with dust? Is it the hood design? Did somebody open up a damper that now he's got great suction and the other guy doesn't? The other hood doesn't. Is dust, we talked about this, is dust coming out the discharge of the suction fan? Ripped, torn filter bags, maybe they're not put on correctly. A thing to do is you do all these things and fix it. You got to remember, you still got some material that's in that clean air section now that's dropped out. That's still going to continue to vent every so often. So you may have it fixed, but you still got a little product coming out through that fan discharge until that's all settled. Jeremy?
Is the dust dry, wet, or different in any way? Wet indicated, leaks and ducting, housings. Is it happening during rain or snowy weather? Dust can get heavier and it can lay in the line. When it builds up and there's moisture, it can cause, chunks and mud, which can also blind over filter bags. Is it bridged above or below the airlock? Airlock is leaking. Sheet of paper test, or check your clearances. Hopper is full. Is the hopper angle too shallow? Is the hopper outlet too small for the material? Is the airlock stopping too soon after you shut down and clean the bags? Again, the type of material. And then also check the connection under the discharge.
Thanks. Couple more. Does it happen a certain time? Again, we talked about that. Spring, fall, cold weather. Works sometimes when you're running maple wood sawdust, but it doesn't really work that well when it's oak sawdust. We try to figure out what is the issue. Are just the filter bags dirty? Magnehelic pegged out to the right. Is it pegged out to the right because they're dirty? If it's broken, or the gauge is clogged? And dust on a bag is good to a degree. We want some dust on the bags to build up that dust cake. We just don't want it build up so much, or that's what pegs out the magnehelic. And at the same time, it may even build up between the filter bags. There you go, Jeremy.
Are there noises that are new or noises you don't hear anymore? You know, are the belts squalling on the fan? Are the pop-off mechanisms, can you hear them? Are each one of them sounding the same as the next one or the one before? Or is it too quiet? You can't tell. You know, you can kind of, just listening, you can kind of tell about what your pressure is. If it's different, say if it's a VR filter. You know, looking for bearings. Can you hear air leaking into the system? Or is there compressed air that's leaking out? Even your Morse couplings on your, you know, if you have a new jet filter mechanism, your compressed air or your Morse couplings, are they fastened tightly to where they won't leak? Did someone adjust the dampeners? You know, once a system's balanced, it's a great starting point, and it should be marked. And then, of course, over time, someone may move a damper. If someone moves a damper, you need to find out why. Why, you know, was there a choke? Did we put it back? And a lot of times I've seen a lot of places where they actually lock out the dampers so no one will change it, and they actually have to get someone with the key to adjust it. That way it's recorded. I mean, that's a possibility. But that's a lot of the issues when it comes to balancing systems. Lonnie?
And we're starting to get close on time, so let me just finish up a few of these right quick. Pulling good product. We just talked about that. A change in one damper makes it higher velocity in the next one. Are you changing your bags out too often? Maybe your fan speed was designed for this, but you're not running that much CFM, but you didn't adjust your damper, so you're oversped to begin with. Maybe you're over cleaning your filter bags. Jeremy, I'll just finish up a couple of these, but your bag cleaning air power units are getting too hot. There's things that you can do on that to not get it so hot, but at the same time you want it to build up enough pressure and build up enough pressure in the tank. Potential for fire explosion. Are your filter bags grounded? That's one thing you can do to help prevent a fire or explosion. Again, we talked about cleaning valves quite a bit. Each one can be adjusted, not each one, but the system can be adjusted on-off times for your application. Explosion vents. If you got explosion vents on your filter, they are a consumable. They do flex in and out. They're laser cut. They will flex in and out over time. They will fatigue over time. But if you have them, this goes counter to some things we've said, but shut down your timer board with the fan so the housing is not pressurized by the bag cleaning system. This is primarily on smaller filters. On larger filters, it's not an issue, but on small filters like a small central vac filter that's a high vacuum, shut down that timer board with the fan so you're not pressurizing the bag with the cleaning system when you're not running the suction device. And don't feel bad about talking to your supplier and saying, hey, I need a different explosion vent. Is there a better explosion vent for me? And lastly, did it work and now it doesn't? It could be a very simple thing. It's not a set and forget system. A dust collection system is not set and forget. As you increase resistance across the filter bags, you are going to have to open up that damper a little bit more to overcome that additional resistance, so that your dust collection at the hoods and pickups does the same amount of cleaning. So it's a live system. You just got to kind of pay attention to it. When the magnehelic gets high, you're going to have to open up that damper and overcome some of that resistance in the system. And again, explosion protection, again, it's a whole different seminar, webinar, probably days long, with OSHA and NFPA, with the emphasis on dust emphasis program, with the DHA that's supposed to be completed relatively soon. It's important that you know what your filters are. Are they NFPA compliant? If so, filter bags grounded. I'm not an expert, but I think I can remember when NFPA in the early 2000s was starting to make some changes. I don't remember that there was a saying that filter bags had to be grounded. I could be completely wrong, but I think that requirement came into play 2007, 2013, somewhere down the line. So just be aware that if you're making your filters NFPA compliant, let's make sure you have grounded filter bags just to help reduce any potential for explosion. Dust control summary. Jeremy, why don't you just run through a few of these that you see out in the system, out in the world?
You know, change your filter bags when differential pressure is too high. You know, routine checking and changing the solenoids, diaphragms, springs. A lot of times, especially on the new jet filters, it's nice to have a set of those already pre-made, because sometimes when you're troubleshooting those issues, it can kind of get a little complicated, because you've got a couple different diaphragms and there's a bunch of different possibilities. Check your airlock clearances. You know, make sure the fan bearings are lubricated. Check shiz. You know, vibration. When they do change socks, check your filter cages. I mean, that's one thing that a lot of times they'll pop out socks. You know, someone should probably inspect every cage just to make sure there's nothing bent or broke. Your bag cleaning power unit, make sure that inlet filter's checked. Lubricate and make sure the air power unit's lubricated. You know, check the belt. And just the basics. Sometimes there's so many operating systems, or so many things operating on a filter, that you got to check all the little stuff. Sometimes it's the simple stuff that causes the issue. Go ahead and next.
Okay. This is a slide on maintaining the solution. It will be on the PDF that you can get, and you can get the webinar. We're running out of time, but I just want to say, to review, it's things we've talked about: after installation balancing, allowing for the future. Keep in mind some of those things as you go through your system. Again, you can get a typical air measuring kit and learn how to use it from us, from others. It helps you help us, and helps us help you. There's problems, again, as Jeremy just said, we look for the simple things, and that's what we try to fix first. Then when we run out of simple stuff, that's when it gets complicated. Fan rotation, ductwork orientation, leakage, again, all common things we try to resolve. Application, maybe somebody's beating on a hopper. It's just not going to come out of that hopper anymore, so beat up. In closing, understand the equipment and the process, both in optimal and upset conditions. Rely on your supplier. You bought a quality piece of equipment, whether from anybody, it's going to be a quality piece of equipment. Give them a call, let them help you. Try to learn and identify issues before the failures occur. regular and effective maintenance, and be safe. That's as much as anything in these days, be safe. So Kendall, I'll turn it over to you with questions. Again, thank you very much.
Thank you so much to both Lonnie and Jeremy for a great presentation today. We are running a little short on time, so we'll just go through 1 or 2 questions this morning. Okay, our first question, do you recommend a bag filter or a cartridge filter?
Jeremy, I'll take this one. It depends on the application. It's important to not just assume one or the other, but talk to your customer. What do they have room for? What have they had success with? What are their height requirements? Do they have a standard filter they want to stay within? That kind of thing. So it's not as simple as saying one or the other. It's about understanding the customer's needs.
Okay, and our second question, what are some quick tips for how to improve pleated bag life?
I would say confirm with a pleated bag manufacturer the air pressure it takes to clean those bags. Because if it's 50 psi, if you've only got 50 psi and you need 90, you're not going to blow that dust out of there. I would confirm with your pleated bag manufacturer, how many pleats do I have? 45 pleats has a lot more area than 30 pleats, but 30 pleats has a bigger vortex that allows more of that dust to come out. Also talk to them about, do I have the right treatments on that pleated filter bag? So again, it's talking with your supplier about solutions for you.
Thank you so much. That is all the time that we have for questions today. I do want to thank everyone for their participation. If your question was not answered on air here today, it will be sent forward to our presenters. And that is all that we have for you today. I want to thank our presenters, Lonnie, Glen, and Jeremy Rupp, and also Kice Industries for bringing you today's webinar. As a reminder, this webinar session has been recorded and it will be distributed to all registrants tomorrow. It will also be available for viewing on grainnet.com within 24 hours. I want to thank everyone for attending today, and I wish you all a great day.